Voyager 2. Voyager 2 is a space probe launched by NASA on August 20, 1977, to study the outer planets. Part of the Voyager program, it was launched 16 days before its twin, Voyager 1, on a trajectory that took longer to reach Jupiter and Saturn but enabled further encounters with Uranus and Neptune. It is the only spacecraft to have visited either of these two ice giant planets. Its primary mission ended with the exploration of the Neptunian system on October 2, 1989, after having visited the Uranian system in 1986, the Saturnian system in 1981, and the Jovian system in 1979. Voyager 2 is now in its extended mission to study the outer reaches of the Solar System and has been operating for 42 years, 1 month and 2 days as of the 22nd of September 2019. It remains in contact through the NASA Deep Space Network. At a distance of 120 astronomical units, 1.80 times 1010 kilometers, about 16.4 light-hours from the Sun as of February 25, 2019, moving at a velocity of 15.341 kilometers per second, relative to the Sun, Voyager 2 is the fourth of 5 spacecraft to achieve the escape velocity that will allow them to leave the Solar System. The probe left the Heliosphere for interstellar space on November 5, 2018, becoming the second artificial object to do so. It has begun to provide the first direct measurements of the density and temperature of the interstellar plasma. In the early space age, it was realized that a periodic alignment of the outer planets would occur in the late 1970s and enable a single probe to visit Jupiter, Saturn, Uranus, and Neptune. By taking advantage of the then new technique of gravity assists. NASA began work on a grand tour, which evolved into a massive project involving 2 groups of 2 probes each, with one group visiting Jupiter, Saturn, and Pluto and the other Jupiter, Uranus, and Neptune. The spacecraft would be designed with redundant systems to ensure survival through the entire tour. Constructed by the Jet Propulsion Laboratory, JPL, Voyager 2 included 16 hydrazine thrusters, 3-axis stabilization, gyroscopes and celestial referencing instruments, sun sensor, Canopus star track, to maintain pointing of the high-gain antenna toward Earth. Collectively, these instruments are part of the Attitude and Articulation Control Subsystem, AACS, along with redundant units of most instruments and 8 backup thrusters. The spacecraft also included 11 scientific instruments to study celestial objects as it traveled through space. Built with the intent for eventual interstellar travel, Voyager 2 included a large, 3.7 meters parabolic, high-gain antenna, transceive data via the Deep Space Network on the Earth. Communications are conducted over the S-band, about 13 cm wavelength, and X-band, about 3.6 cm wavelength, providing data rates as high as 115.2 kilobits per second at the distance of Jupiter, and then ever decreasing as the distance increased, because of the inverse square law. When the spacecraft is unable to communicate with Earth, the digital tape recorder (DTR) can record about 64 kilobytes of data for transmission at another time. Voyager 2 is equipped with 3 multi-100-watt radioisotope thermoelectric generators, MHWRTG. Each RTG includes 24 pressed plutonium oxide spheres, and provided enough heat to generate approximately 157 W of electrical power at launch. Collectively, the RTGs supplied the spacecraft with 470 watts at launch, having every 87.7 years, and will allow operations to continue until at least 2020. It was originally thought that Voyager 2 would enter interstellar space in early 2016, with its plasma spectrometer providing the first direct measurements of the density and temperature of the interstellar plasma. In December 2018, the Voyager project scientist, Edward C. Stone, announced that Voyager 2 reached interstellar space on November 5, 2018. Once its planetary mission was over, Voyager 2 was described as working on an interstellar mission, which NASA is using to find out what the solar system is like beyond the heliosphere. Voyager 2 is currently transmitting scientific data at about 160 bits per second. Information about continuing telemetry exchanges with Voyager 2 is available from Voyager Weekly Reports. Voyager 2 is not headed toward any particular star, although in roughly 42,000 years it will pass 1.7 light-years from the star Ross 248. And if undisturbed for 296,000 years, Voyager 2 should pass by the star Sirius at a distance of 4.3 light-years. Voyager 2 is expected to keep transmitting weak radio messages until at least the mid-2020s, more than 48 years after it was launched. As the power from the RTG slowly reduces, various items of equipment have been turned off on both spacecraft. The first science equipment turned off on Voyager 2 was the PPS in 1991, which saved 1.2 watts. Each Voyager space probe carries a gold-plated audiovisual disc in the event that either spacecraft is ever found by intelligent life forms from other planetary systems. The discs carry photos of the Earth and its life forms, a range of scientific information, spoken greetings from the people, e.g. the Secretary General of the United Nations and the President of the United States, and the children of the planet Earth, and a medley, Sounds of Earth, that includes the sounds of whales, a baby crying, waves breaking on a shore, and a collection of music, including works by Wolfgang Amadeus Mozart, Blind Willie Johnson, Chuck Berry's Johnny B. Good, Balya Bakanska, and other Eastern and Western classics and ethnic performers. Thanks for watching. Subscribe to Footprints for more videos.